Hi there and welcome to Cambridge Advanced Level Mathematics. We've got a beautiful question for today's lesson. It's taken from paper 1 of 2022, question number 7. And I've got on the board there a nice, look carefully, it's a nice little picture with a blue graph and a red graph and so forth. What does it represent? Well, this red graph is the function of y is equal to half x plus 1. The blue graph is the function of a function of y is equal to 3x minus 2 to the power half. And I've indicated on the diagram, on the graph, the values of x at A, the values of x at B. They are x1 and x2 respectively. So what's the big deal? Well, the examiner wants us to calculate the values, the coordinates, of the points A and B. And that will be our first question. The next question, we'll be talking about calculating the area between these two graphs. But before we get there, let's deal with the first part. Let's calculate A and B. And I'll tell you what, this question is really rich in marks, and I can't wait. Okay, so coordinates of A and B. Well, these points are points where the two graphs are intersecting each other. So where they intersect, surely the value of y here and the value of y there must be the same. So we can equate this to that. Let's do it. So we have half, okay, let's start with the other one there. Yeah, okay. We have 3x minus 2 to the power half is equal to half x plus 1. Of course, we can write this as putting a common denominator of 2. We have 1 over 2 bracket x plus 2. Okay, so that's the equation there. We can simplify things. This is raised to the power half, so let's square both sides to get rid of the square root sign. So we can write 3x minus 2. Now we have removed the square root sign, and the half squared power is equal to, we square everybody here, that becomes half squared is 4, multiplied by x plus 2 squared. What does that give us? It gives us 1 over 4 bracket x squared plus 4x plus 4. Okay? Why don't we multiply everything by 4 to get rid of the quarter there? So we come over here and we say 4 multiplied by 3x minus 2 is equal to x squared plus 4x plus 4. Open the brackets here. We get, that gives us 12x minus, that gives us 8 is equal to x squared plus 4x plus 4. Why don't you get a pen that writes better? There we are. Okay. So, of course, we can collect all the like terms and simplify. That gives us our x squared. 12 goes over here. It becomes a minus 8x. And 8 comes over here. It becomes a plus 8, which is plus 12. And that is equal to 0. Because we took everything here and put it that side, so we're left with 0 there. So that's our quadratic equation right away. And we can solve it. Looks like it can be factorized. So let's go ahead and factorize it. This becomes brackets, 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 there, x there, factors of 12 that subtract to 8. Is it 3 and 4? No. Is it 1 and 12? No. Is it 2 and 6? Yes. So 2 minus 2 times minus 6 gives us a plus 12. And yet minus 2 and a minus 6 gives us a minus 8. So we need a 6 here and a 2 there, and both of them are minuses. So of course this will be equal to 0. Immediately we can conclude that x is either 2 or 6. So the values of x that satisfy this equation are x is equal to 2 and x is equal to 6. What are the values of y when x is this value? We can use this simple equation here. Let's put x is equal to 2. We then have half of 2 plus 2, which is equal to half of 4, half times 4, which is equal to 2. So when x is 2, y is also equal to 2. So we have the point 2, 2, which should be the point A there. What about the point B? Point B, let's put x is equal to 6. We will have half of bracket 6 plus 2, which is 8 divided by 2, which is 4. So the coordinates of B, so this will be A. The coordinates of B will be 6 and 4. Just to check our calculation, we need to check that the same values of x will give us the same values of y here. Let's quickly do that. So remember, x is equal to 6 or 2. So coming here, when x is 2, we have 2 times 3, which is 6, minus 2 to the power half. That gives us 4 to the power half, which is equal to 2. There is our 2 there. When x is equal to 6, we have 3 times 6, which is 18. So it's 18 minus 2 to the power a half, which is equal to 16 to the power half, and that gives us 4, which is that 4 there. So it looks like our calculations were perfect. Okay, now let's proceed. Let's go a little further with this and proceed to the next part of the question. And by the way, this was 4 marks. That's why I told you this thing is rich in marks. The next question goes like this. Calculate the area between the two graphs. Now the area between the two graphs, we can see the blue graph is jumping over the red graph there at A. It goes and goes and jumps again on the other side of the red line. So the area that we are interested in, the area between the two graphs, is the area that I have shaded green. But how do you find the area under a graph between two limits? Because we need the area. The area is going to be between A and B, where these two, which is the area squashed between these two graphs. They are squashed between the points where x is x1 and x is equal to x2. And by the way, we have just calculated that x1 is equal to 2 and x2 is equal to 6. So we are back to integration now. We know that the area under a graph calculated between two values of x is given by the integral of that function between those two limits. So let's call the area under this blue graph between x1 and x2 and the graph itself. That area, let's call it A1. That area is given by the integral, we're dealing with the blue graph, the integral of 3x minus 2 to the power a half dx. What about the area under the red graph between the same limits? Oh, sorry, we must put 2 here and 6 there. The other graph, let's call it A2. It is given by the integral between 2 and 6 of half x plus 1 with respect to x. So we got the area under the red graph and the area under the blue graph. So the area squeezed in between must be the area under the blue graph minus the area under the red graph. So therefore, let's call that area A0. So we can write here, therefore A0, the green area, is equal to A1, which is the bigger area, of course, A1 minus A2, which was, of course, this integral minus this integral. So we can write it as the integral from 2 to 6 of 3x minus 2 to the power a half with respect to x minus the integral from 2 to 6 of half x plus 1, or with respect to x. This is a straightforward integral, but this one is a little tricky. So let's deal with this for a minute. And I would like us to forget about the limits for a minute and just deal with the integral. Then we will come back to the limits. Which part shall I think, of course, we remember this. So let's deal with the integral. We'll come back to this formula in a minute. So this thing here. Now, this looks like a situation where we need to resort to integration by change of variable. But remember, the integration, we did that in a couple of videos ago. We did that, and we found that the functions that lend themselves well to change of variable method are the functions that are, the integrals that are of the form integral of f of x, maybe to some power n, multiplied by f prime of x dx. These lend well because when we then start manipulating them, this then becomes, supposing we want to change everything in terms of u, then this becomes, this f of x, f prime of x dx becomes our du, and this inside the square box becomes our u. So of course it will be u to the power n. So we turn everything around and put it in terms of u. It now becomes the integral of u n du. Okay, but this one here, it's not in this form because we know that the derivative of this thing here inside the brackets is 3, and we don't have a 3 here. So why don't we try some panel beating and do this? Okay, so we can do this. Again, let's forget the limits. They just stand in the way. So we are going to say, let this be equal to, we can say, all right, we can write this as the integral of 3x minus 2 to the power a half multiplied by 3 dx. Now this is now f of x multiplied by f prime of x dx. But we have introduced a 3 there, so we need to bring it over here and divide by 3. So we can say this divided by 3. When we have done this, we haven't robbed anybody because this 3 cancels that thing. But now inside the integral sign, we have got our function in the form that is easily manipulated to the change of variable method. Because now this thing here, this now becomes our du. Remember, f prime of x dx becomes du. And here it becomes u to the power a half. So our integral now becomes nice and cute. It becomes 1 over 3 integral of u to the power a half du. Just like that. Now we can simplify everything. But now, before we go to integrating this thing, let's introduce the limits. Let's bring back our limits. We have said our 3x minus 2 is u, which is raised to the power that, and of course here it's raised to the power half as well. So our u, in this case, is equal to 3x minus 2. So what is u when x is 2, the lower limit? So we can say u of 2, because u is a function of x. When x is 2, what is u? U will be equal to 3 times 2, which is 6, minus 2, which is 4. Okay, what is u of 6? U of 6 will be equal to 3 times 6, 18, minus 2, which is equal to 16. So when we have changed our variable to u, we now integrate from 4 up to 16. Okay? Okay? So let's clear some space here. This, of course, becomes power rule there. We have 1/3 outside, of course, multiplied by, we raise the power by 1, it becomes 3/2. So we divide by the new power, it becomes 2/3. So 2/3 here, multiplied by u to the power 3/2. This, of course, integrated from 4 to 16. So we can say this is equal to 2/9, 3 times 3 there, u to the power 3/2, from 4 to 16. Let's evaluate. This is 2/3 bracket. When u is 16, what is the square root of 16? It's 4. Raised to the power 3, it's 64. When u is 4, we have square root of 4, which is 2, raised to the power 3, which is 8. And we finally get 64 minus 8, which is 56. 56 multiplied by 2/3. Oh, no, 2/9, sorry. 2/9. So it's 56 times 2, that, divided by 9, which is that. I'm getting here an answer of 12.444. That is now our A1. Okay, let's deal with this part there. Throw away this stuff. Okay. Be sure you understand this process. So that one there, it's pretty simple, isn't it? It's from 2 to 6 of half of x plus 1 dx, which of course is equal to, this becomes x squared divided by 4, which is 1/4 x squared. That becomes just x. And we are evaluating this from 2 to 6. When x is equal to 6, sorry, this is 36 divided by 4, which is 9. 9 plus that there, it will be 6. So it's that, bracket, minus, when x is now equal to 2, we have 2 squared is 4. 4 divided by 4 is 1. And that, of course, is just plus 2. Simplifying, we have 15 minus 3, which is equal to 12. So A2 is equal to just 12.0. So we said our area is A1 minus A2. The area under this here minus the area under that. And this gives us 12.44 minus 12, which is equal to A1 minus A2, which is, of course, 0.444 units. That is the area of our green, our green region there. So this, of course, was but was with 5 marks, so total of 9 marks. If you know your integration techniques, you shouldn't have a problem here. The first part was pretty straightforward, and as far as I'm concerned, it would be ordinary level stuff. Equating 2 equations and solving for x and so forth, pretty easy stuff. But that's the question there. That's the end of it. Till we see you, we ask you to subscribe if you are the first viewer, and also to press the like button. It's always good for us. Till we see you again, thank you.